Hello, everybody, and welcome to the April 2023 meeting of the Howard Astronomical League. Let me bring up my slides and share my screen. Oh, I'm going to make it so that others can share the screen too if they need to. But let me share my screen. If I can remember how to do that. Did they upgrade this thing? Because I don't see the
It's at the bottom, isn't it?
security chat. Oh, there it is. Share screen. And I'm going to share screen too. And anybody see my slide?
Sure can.
Okay, so again, welcome to the April meeting. Our agenda for tonight is we'll just go around and have some introductions. We have a few announcements to make. We had an excellent featured speaker that would have been joining us from Australia, from the Deep Space Comm Network complex, where they have all the big dishes that talk to the deep sky stuff. He had an unavoidable conflict, and so he couldn't make it, but he has agreed, and we had the slot open for next month. So he's actually going to be our May speaker. So we have that to look forward to. And then after that, we'll do our what's out in the sky, go through a few images, and then wrap up the discussion, wrap up and have a discussion. Maybe at that point, I'll stop the recording, but I wanted to also just sort of talk about the club and get some feedback from members on things that they would like, or what anything that we want to do new in the club. So without further ado, I would say, is there anybody new to the club on right now? If you are, you can say hello.
Hi, can you hear me, Victor?
I can.
Okay, it's showing up as Angela, but my name is Jim Wassel, and I actually work with Victor, but I've been meaning to come to a club meeting for a long time, and happy to be here for the first one.
I'm super happy that you're here. I saw Angela and I was wondering where I was hoping you were going to make it tonight. So that's terrific. Welcome. Jim is a very accomplished amateur astronomer. He's got some nice gear. Oh, and if anybody would be kind enough to monitor the chat, I'll put the chat window up. But if anybody sees anything that I missed that I need to address, please let me know. So, great. I'm glad you're here, Jim. Anybody else? I guess I do see a lot of familiar names. So, okay, well, next up is announcements. So, everybody still seeing my screen? Yep. Okay, so announcements, star parties. We have a star party this weekend, this Saturday. I'm not sure that the weather forecast is looking great, but you know, it's iffy. It could, if the clouds move in just a little earlier, we might get some rain early in the day, but we might get some clear skies. So rain or shine, there will be people there. So I hope some people come out. Last month's public star party was kind of clouded out and foggy and rainy, and there was still a number of people came. Like, I think we had over 100 guests last time, so that was terrific. And then regional star parties that are coming up. It's not really a star party, but it's the MEF forum in New York, and so I was going to Arjun. I would invite anybody who was at MEF and wants to talk about it. I would welcome you to, if anybody would like to share their experience.
I don't see the regular crew on that I know went.
Yeah. Arjun, do you want to say anything?
Yeah, sure. So, first off, I'll just start off by mentioning a few new products which I saw over there.
So the one thing which I saw was the Red Cat 61. So it was like a jump between the 51 and the 71, and it was just about the same size as the 51. So it seemed like a really nice scope. Another thing is the
They changed the focuser on it, right?
yeah, yeah, it was a rack and pinion focuser.
Yeah.
Another product which I saw, ZWO released multiple products. They released an ASI Air with 256 gigabyte storage on it. They also released a new telescope called Sea-Star. It's like an automated one, similar to like Stellina and other stuff like that. And they also released a rotator, it's like similar to other rotators. So they released that. And there were also lots of other vendors. But these were the main ones which I saw.
Awesome. I actually didn't know about the rotator. I need one of those. I'd like to look into that. Thanks.
Yeah. Anyway, I just wanted to put one more thing out. So I also attended NIAC, and one software which I might recommend is Cyril, because Nico Carver, the astrophotographer, he did a talk on it there, and it was actually really good. It had lots of capability. So he was like using it as an alternative for PixInsight. So like for anyone who doesn't use PixInsight, you might want to try to use Cyril.
Cool.
How do you spell that, Arjun?
It's SIRIL, and it's open source software.
So did he say anything like, if you're somebody who already has PixInsight and uses PixInsight, is there a reason you'd want to use Cyril as well? I've already paid for PixInsight for a lifetime license.
I mean, it depends. Like, if the learning curve for both of them is pretty similar, but it features the same capabilities like background extraction, curves and everything. So I'm not sure why you would want to switch. Like, if you already have PixInsight, it's okay. You can just keep it.
All right. Oh, it's free, so it can't hurt to give it a try. Thanks.
Yeah.
I appreciate that.
Put that in chat, please, Arjun, so everybody could click on it.
Yeah, the other thing, actually, sorry to keep bugging you, Arjun, but our member who's not here tonight, but Dale Gent gave a talk on Nina there, right? And how did that go? You're muted.
Oh, me?
Yeah, did you see his talk? Were you able
Oh,
to-
right. I totally forgot to mention that. So there were a few other talks, but Mr. Dale's talk was on the new Nina upgrades. And basically he was just saying that there were a few plugins which made the software better, and it was a better user interface, and it was also faster. That's one thing she said. He also gave a few updates on Nina 3. So he was saying that Nina 3 is in progress, like we could expect it sometime next year or at the end of this year. And he told us that Nina 2.2 would solve all of the problems which we already had. I'm just not able to grasp on which one specifically, but he just said not to be scared of it, and it's actually a big upgrade and it would be really nice.
Cool.
Another talk which was there was it was about gravitational wave observations. And so basically they were saying how gravitational waves sometimes emit visible light. And so if you join the program, you can listen for their calls and observe that area of the sky if they ask for it.
Interesting. All right, we got to find a speaker to talk about that.
Yeah.
Just to add on that, which Arjun is not adding right here, is for our generosity of our member Dale sponsored Arjun to attend NIAC.
Yes. Mr. Dale actually gave me his ticket, and also Mr. Bob Moore sponsored me also, since I'm a student. And there's so much to say. I just keep forgetting what to say.
All right, well, we're make some notes. We'll have some time to just shoot the breeze after our after we get through the meeting. So great.
Yeah, but please, everyone give a huge thanks to Mr. Dale. He's actually a really kind person, and I'm really thankful for him.
That's terrific. We are too. Okay, so thanks. Thanks very much, Arjun, for that update. The next topic is Astro-school. Phil, you want to talk about Astro-school?
Yes, Bob is with me, Bob and I, Bob Savoy.
Oh,
and-
Bob's here, right?
Yeah, Bob and I are, let's call us co-chairs, if you will, for Astro-school. And we had our first event, which was at the planetarium at the Robinson Nature Center, the second Thursday of April was, and we had 25 members there. And it went really well. People seem to enjoy it quite a bit. I'm going to ask Bob to talk about it a little bit. I just want to say, though, that I put in an email, but everybody should really appreciate how much work Bob put into that. That wasn't some pre-canned presentation. He put, at least according to the Robinson Nature Center people that I talked to, he put at least 25 hours of real work into prepping for that thing. And it was very much appreciated. What was that, Joel?
I said, I can attest to the amount of hours to get it right.
Yeah. So Bob, you want to talk about the event a little?
Just a little bit. Josh was the operator for that, and Josh was only at the Nature Center for 4 months. That's all. And so between the two of us, I supported him and he supported me to get the show all together in that 25 hours. And he's got a full-time job right there at the Nature Center besides. And so there was a limited amount of time for me to spend with him. However, Ellen Reinecke, the program manager, has let me view some of the training films that Digistar has given to Robinson Nature Center. And so I've been reviewing those training films, and Joel, you will probably remember how quickly it comes back to us. And so I'm eager to get into the planetarium again so that I can work on it when it's not being used for a show or for a camp or for practice by the other staff members. So I'm really glad that I was back to the Nature Center planetarium again. That was a lot of fun. And so I'm hoping that maybe we can have another planetarium show and show some other things in Astro-school in the future. So that's it.
Great.
So Bob and I haven't selected a topic yet for the second Thursday of May. We'll get that figured out. If we do, we're gonna let the people at the Nature Center know we'll be there, and we have a room. They have a room for us to use. So we got suggestions from people that were there. If anybody's got a suggestion on what you would like to cover, we'll find a subject matter expert, and we'll jump right in that. So Bob and I will talk over the next week or so, and we'll pick a topic and make sure we're both available, and we'll go from there. The other thing we're gonna do for Astro-school is I'm gonna pick a Saturday, and if whoever can make it, can make it. If I could do it the same day as a star party, we could be out there during the daytime and do solar at the observatory. So we do a solar Saturday where I can show people how to do the solar imaging and the different ways of doing solar imaging and solar observing, and to make a day out of it. So watch your calendars for that for Astro-school.
Great. Thanks. I can tell you that I really enjoyed it. I think it's great to be able to use the dome, use the planetarium to teach. You can sort of have it all right there. The demonstrations of that you did, Bob, of the sun's path across the sky. I have two teenage girls who were, they were into it. They enjoyed it. So it was really, even you had a tough, they're tough critics. So, anyways, okay, thanks. So yeah, as Phil said, if you have to, do and learn. Next, Crystal, you're up.
Yeah, so this was actually last month's book of the month, but I figured I'd feature it here since I didn't have a chance to talk about it. But this book of the month is Bad Astronomy by Phil Plait. I found it super enjoyable. It's absolutely a great book to recommend for those who are just discovering their interest in astronomy. I'd say that the author doesn't really overwhelm the reader with too much scientific jargon or mathematics, but he really takes a masterful approach to just common misunderstandings through this really engaging storytelling. I learned that I was answering the question, why does the moon look so big, so much bigger on the horizon, with the wrong science. Believe it or not, the real answer involves more human psychology and how a brain interprets size versus distance than the physics of light. The author interweaves like a bunch of personal anecdotes, history, pop culture, these super descriptive analogies, and really informs the reader of nearly 24 persistent astronomy myths and just general myths and understandings. Even, I think, an experienced astronomer will really find some helpful and possibly new ways to answer really common questions. Sure, you could answer like, why is the sky blue because of quantum effects involving Rayleigh scattering? But I think this book offers a more down-to-earth response to that question.
Cool.
I'd say coming in at under 300 pages, it's an easy weekend read, and it's already available in the HALO library. Fun fact, I didn't make the connection when I was reading this book, but this author is the same guy who does the popular YouTube series Crash Course Astronomy. So all those introductory astronomy YouTube videos, I use them in my class all the time. It's the same guy, so I didn't realize that.
Cool. And so it's in the library, and it's
Yes.
also, is it like Amazon, and is it an ebook too, or?
Yeah, so it's been around for a while. I don't remember the publisher year, but it's definitely available digitally, and we have one physical copy in our library collection.
Awesome.
Hey, same news of library stuff. It's not official yet, but I am working on creating a digital checkout form. So we have pieces of paper in the HALO space that you can like write your name in the books you're checking out. But for those of you that would just like to browse the library catalog and maybe check things out in advance, or just interested in having a way of checking out and returning using a digital format, stay tuned. We will have a digital option to check out books very shortly.
Awesome. Thank you. Love it.
Could you repeat the name of that YouTube channel, please, Crystal? Thank you.
Yes, it's called Crash Course, and Crash Course actually does a series of different topics, and he specifically is the host for Crash Course Astronomy.
Can you put that in chat, please?
Yes, and I'll put it in chat.
I don't know if anybody ever knows this, but the chat log is recorded, and I think it Ken puts it up on the with the rest of the digital archives of the meetings, so you can go online and read all the, if there's something in the chat that you see and it's of interest, you can find it later on our website. Okay, awesome. Thanks, Crystal. Next, so we're gonna again, no speaker tonight, but we kind of have our own speakers because we have so many cool people in the club who know so many things. So that first up for that is Bill.
Hi there. So the sun has been very, very active lately, and I didn't take any images yesterday, but it was quite spectacular. I don't know if anybody had a chance to view an HAL or looked at it online, but there was a very, very large prominence. And what's interesting is not just the size of them, but the shapes. It's almost, with the exception of some loops, it's almost like there's no two are exactly alike, and or that even similar. But there's also an awful lot of surface activity. But what we're looking at here, this image, as you can see, I took on April 4th, and I was using my ZWO one-shot color camera. It's the 2600 MC Pro, the same one that Victor broke. He broke his own, not mine. And it took me a little while to figure out how to use the one-shot color camera when imaging using hydrogen alpha. I had to set it for sRGB because anything else, you only use the red pixels, and then you get to see the raster behind in every single image. It was pretty frustrating until I got that figured out, and got the balance focus and the balance and the focus and everything together, and the results have come out very nicely. So you could see on here, these are, out here and over here, you can see these are called prominences. I'll come back to these in a second. This area, these.
I don't see your mouse.
Oh, you don't see my, oh, you can't because you can put prominences. Victor, you can see what they are. I can't, you can't see what, there you go. And then, and you get a closer up view on the picture on the right. And then the black lines, those are filaments. And if you don't know, if you haven't heard my talks before, you don't know what these are, I'm going to tell you right now.
They're named after you, right?
Yeah, right. Except spelled a little differently. So, and they're not that minty, but the filaments, what they are is they are exactly the same thing as the prominence that you see coming off the edge, except that they are facing us edge on. So as the sun rotates around, and I do have some other images in my own personal archives there where you could actually see where I took images over different days, and as the sun rotated around, you watch that filament, then you can watch it come right off the edge as a prominence, and that really helps. And I've got other images that show a filament at the edge coming out, and then you have a prominence coming off of it. So it really makes it much easier to see what's going on. But when you look at these filaments, you have the sun is 880,000 miles in diameter, where the Earth is 8,000 miles in diameter. So if you were to put the Earths side by side, you put 100 to 110 Earths side by side to go from edge to edge there on the sun. And so it gives you a really good perspective of how long those filaments are. And some of those right there in the center are 200,000 miles long or longer. And if you straighten them out, they're close to 400,000 miles long. So it is, and you can't really tell how far off the surface they're coming pointed at us. Like the one on the right is probably approximately 50,000 miles off the edge, from the edge of the sun to the top. And I've some other images where I've actually put the Earth in there to scale, so you can really get a good view of what's going on. And there's a faint prominence off on the left. The brighter areas, especially you can see it on the right side there. But usually where there's a sunspot, you get a really bright white area. I don't know if you have another picture after this of the sun or not, Victor, if you just use this one.
I just use this one.
Okay, so there's some, and the plages are French for beach because they look like a beach when you're looking at them on the sun. They're very white, they're very hot. And like I said, they usually surround a sunspot, and that's where the coronal mass ejections, or the CMEs, come launching out of for the most part. And when they're Earth facing, you get those big solar storms, and it lights up the auroras, and if it sends enough ionized plasma and hits our magnetosphere and bends it into the Earth, it's what will cause the problems with power outages, knocking communications out, and all kinds of bad things happen. And it has happened several times in history.
So we're coming into a solar maxima. Are we there yet? What are we?
Oh, we're still early on. For all practical purposes, we're about 2 years to 3 years away from solar maximum. Although I saw a news story that said whoever they are is predicting that solar maximum may come earlier this season. Personally, without showing the science on how that comes up, I think it's just somebody's opinion because we have an extraordinarily early active season. And for everybody else who may not know this, the sun has 11-year cycles, approximately 11-year cycles. And this is solar cycle 23, I believe, from the time we started counting them. And it's 23 or 25. Bob Dutili's not on. He usually catches me up on that, but it's 20, whatever it is. So nevertheless, we're a few years into it, and we're already super active. We're already more active by far than the most active time there was in the last solar cycle. And that solar maximum maxed out in 2013, 2014. And it was nothing like this as we're building up. So realistically, we have about 5 years, the next 4 to 5 years of a really active sun, which is awesome for those of us who observe and who like doing the pictures and talking about this stuff. And it isn't so awesome for the people who are responsible for protecting our satellites, the people on the space station, and the power grid and GPS and all that other stuff. And
I think you're making me excited for finding a solar expert to come and give a talk to the club.
so I'm it's really good. Any
If
questions?
anybody on knows somebody at NASA or JPL or something, can you maybe shoot me an email with their contact?
Phil knows more than any of them.
But say again?
Said Phil knows more than any of them.
Right.
But there
Okay.
Goddard's got the solar, has some really excellent solar scientists there who have helped me out in the past trying to figure out some features that nobody else could figure out. So
I'll talk to you offline. Maybe I can reach out to them if you got a name or a contact.
I'll have to-
How about an update from Parker people?
Oh yeah, them right. Yeah. We're right in the middle of that, right? It's
Yeah.
Yep.
So, hey, Victor, maybe this is a good time, although it's a little off subject, but along with these talks and speakers, I was just at the National Association of Broadcasters Conference for the last several days in Las Vegas, and I ran into somebody at NASA Huntsville, that I have worked with for the past 30 years. And he's one of the people at the lead for the digital television group, the digital TV group for NASA, which is headquartered out of Huntsville. And they do all the coordination. NASA used to be completely uncoordinated. One base didn't talk to the next. And the DTV group came in and took over the coordination of all this stuff. And they do incredible things. But this individual that I was talking with, he told me he's tied to the Artemis mission. And he's working on the design for the cameras and everything else that's going to, for everything from launch to what's going to be on the moon. And, it's got to survive all the conditions and everything that's going on like that. So I talked to him about doing a presentation for us here at HAL, and he said he would do it.
great.
He would be very interesting. He's a really good guy. And he's at NASA. He's a contractor for NASA.
If you want to arrange that, or if you want me to arrange it, let me know. That's terrific.
Yeah,
Let's talk
so-
about it offline.
and that's it. Thank you.
All right, cool. Thank you. Anything else on this? This isn't just an awesome picture. I love looking at it.
Yes, I have one more thing, Victor. I tried to get Nikki Fox to come and speak to the club before the pandemic, when APL was making a big deal of the Parker Solar Probe. And I was not able to get in touch with her. And I believe now that she is at NASA at Goddard Space Flight Center. But Nikki Fox made a presentation that was fantastic. She's really good with people, and I don't know if she's available or not, but Nikki Fox.
NICKY.
I
NIKI, I think it is.
think it is, yeah.
NIKI. I'll look her up and just reach out. Is it 2 X's or, well, I'll figure it out. Thanks. That's a good lead.
You're welcome.
I would love to hear about the Parker probe. Do you have a personal, can I reach out and say Bob recommended me? We'll talk about it offline. Yeah, let's talk about it.
Yes, yeah, you certainly can, but I'm not sure she'll remember me at all.
All right. Well, yeah, we'll talk offline about it. That's great. Thanks for the lead.
Sure.
Okay, so next up.
Arjun has his hand up.
Sorry.
Arjun has his hand up.
Oh, great. Thanks.
I just wanted to say, I have one more person who could possibly present. Her name is Alyssa Pagan, and she presented at NIAC. And she works on Hubble and processing data from it. And so I think I could possibly get her in touch with you guys.
That's awesome. Let's at the end of the meeting, let's have another little round robin about all this. Maybe it's somebody Wayne knows too, but let's thanks, Arjun, appreciate that. So I'm going to move on to our shallow sky section. Jim.
Hey guys, so basically probably the biggest thing going on right now planet-wise is Venus. Right now it's a nice fat gibbous, and between now and our next meeting it's going to go from 70% down to 55%, and this is a really good time to kind of look at Venus, especially for something called cusp caps. If you've looked at Venus before, most of the time, the only real thing that you can kind of easily see from it is just the changing of the phases, which of course was really very important to Galileo way back when, because it proved the Copernicus theory that, the sun was the center of the solar system. But beyond that, you actually can tease out a little bit of detail, and this is a good time to try to do that. If you are interested in looking at these cusp caps, and actually this is a real feature. What they've kind of determined is that you have these very large, what they call planet scale Hadley cells, where you have the heat rising at the equator, comes up to the mid-northern latitudes, and then comes down. Where it comes down, it can actually be cooler, and it can make like a little bit of like a dark line. And then above that, at either the northern or southern polar regions, you have this brighter area of the cloud. So it really is, it's not just a visual artifact, it really truly is there. And so if you want to try to see it visually, the first thing you have to do with Venus is definitely kind of do something to get rid of the glare, because it's just so intense. So, even if you have like a moon filter or something, a neutral density filter, anything along those lines can certainly help. Another thing that really helps with bringing out these cusp caps is a violet filter, a Ratten number 47. And those filters are not terribly expensive. Ratten filters are, I think you can be had for anywhere between $15 to $25. And that will also bring down a lot of the glare and allow you to hopefully distinguish these cusp caps. And you don't need a large instrument either. It's not like you need a 10 or 12-inch scope to see these. You could probably pick these out in a, even 70 or 80 millimeter scope. So that would be one thing to do. If you're interested in trying to capture them with imaging, if you're doing any sort of planetary imaging, filters are, again, kind of like a prerequisite to try to get anything. So ultraviolet is really the way to go with Venus. Unfortunately, those ultraviolet filters are pretty pricey, but they are fairly good at actually drawing out some cloud detail. You have to kind of really work your image a bit in Registax to kind of, because these aren't robust features, you know, they're subtle, but you have to kind of up the wavelets to kind of make them visible. But an ultraviolet filter is definitely great. An IR filter is a little less expensive and also a little easier to come by. But while that'll give you a much cleaner image, it is very difficult to pick out any cloud details with an IR. Damian Peach and Pellier, who wrote that great book about planetary astronomy, both of those guys suggest that using one of these cheap Ratten filters, a 47, and then getting an IR block, you want to basically block out some of the infrared light. Even though you don't see it with your eye, the camera will see that. And the Ratten 47 does have an IR leak. So if you combine your violet Ratten 47 with an IR block, you can get some pretty good details. It's not as good as having a UV filter, but you can, for a lot less money, potentially get some good results of actually seeing some cloud detail on Venus. So if you're interested in that, you can also check out the Alpo website. Their gallery there has a lot of contributions for people who are able to use these filters and see some details. All right, next click, Victor. So Mars is up there. It's now down to like Mercury size. It's, I think, 6 arc seconds now, heading towards 5 arc seconds. So realistically, you're going to be hard pressed to probably see much of anything. On a good night with some steady seeing and ranked up magnification, you might see something. You can still do some imaging if you're into that. It's a little bit challenging again because it's such a small disk, but you can still pick out some of the major features and maybe even some clouds or other activity that's going on. Next click.
We'll have to see if James Willingham has anything. If there's anything you can see, James will find it.
He will find it, absolutely. And just to mention, Saturn has finally returned. It's kind of emerging from the solar glare in the pre-dawn skies. So it's going to start its 2023-2024 apparition. The rings are just going to continue to close up. I think 2025, you have the equatorial plane crossing where they will be edge on and virtually disappear. So if you haven't seen Saturn yet, you will definitely be struck by how much the rings have closed up between last year, where I think they were like at 16 degrees, and this year.
Hey, Jim.
And so, yeah.
I'd like to pop in for a second. Hey, Bob, you still on? Savoy? So Bob did,
Yes, I had to unmute. Yeah.
Okay. But during the planetarium show, Jim, and for all, right what you're talking about here is Bob did a whole thing on Saturn and showed just exactly how thin those rings are when you're looking at them edge on. Bob, what did you say the spec was on when you're looking at them like you're looking at the edge of a plate?
They're probably thinner than, well, they are thinnest structure to known man. Wow, I got my tongue tied up. They are the thinnest structure known to mankind, probably, because there are 46,000 miles between the inner ring and the outer ring. And the height is maybe a 2-story house, maybe 20 meters. And that's all. And so when you see them edge on, especially through the Cassini images, they are spectacular. I mean, just a thin line. As a matter of fact, I'm doing a presentation in April, both at the Florence Baines Center and at the Ellicott City Center, 50+ Center, on the rings of Saturn. That's it.
Thanks, Bob. Yeah, that's amazing. 46,000 miles divided by 20 meters. That's a pretty high aspect ratio.
Yeah, it's definitely an incredible planet, and obviously anyone that's done star parties and shown people Saturn, it just knocks your socks off. It's just gorgeous. So, but those rings are starting to close up, so enjoy them while we got them. Next slide, Victor.
It's also
The next-
getting, this year, it should be a little bit higher in the sky than it was last year too, isn't it?
Yep, gradually, I think it's going to be going into Capricornus, maybe into Aquarius, probably on the border there. But yeah, it's gradually moving up. And then finally, we have the Lyrid meteor shower, and that's going to peak this Saturday, which of course we know it's going to be cloudy because we have an event. But if it should clear up in the early morning hours of Sunday morning, get out there and try to take a look. This is actually, from what I've read, the oldest known meteor shower. It goes back first noted in literature some 2,700 years ago by the Chinese. So this one has been around for quite a long time. The other thing is that it's known for not a lot of meteors, but you can get some really bright ones out of it. I remember last year I was driving home from visiting my son in Pennsylvania, and as we were coming down 95, just saw one just fall right in front of us. Beautiful, bright, probably almost as bright as Venus. Short-lived, but just gorgeous. So, this shower is known for some really nice, bright, occasional meteors. So, if you're out there for an hour, you might catch one, maybe two spectacular ones that'll make getting up early worth it. There's also actually this time of year, there has been boleoids where some meteors break apart and actually you get some debris, some meteors that fall to Earth. And there's some speculation they've kind of traced back two of these, from one, I think, in the 70s and one in the 60s. They both kind of had a similar orbit. And so they're wondering if there isn't perhaps some debris from like an asteroid seems to come from the direction of Corvus the Crow, which is kind of out but down low in the south. So again, who knows, if you're out observing on Sunday morning, maybe something from this unknown asteroid breakup might hit the atmosphere, and you might get to see that too. So always exciting with a meteor shower to just kind of see what turns up.
Jim, I have a question for you.
Sure.
Do you know what comet the Lyrid showers come from?
I've read it this week, Bob, but I don't know the name off the top of my head. I should have made a note, but you can Google that. It'll come up pretty readily.
Sure, of course.
It has a very long period, that I know.
All right. Thanks. All right, next section is Wayne, you're up for, we went to the sun, we went to the near in space. Now things that are up in space doing measurements is the next regular feature here. So you want to go?
Okay, we're gonna stick with Saturn here since Jim led into it. And I'm going to be talking about a recently published article in the publication, the Planetary Science Journal. It's published in March 2023. And it's going to be a little different because we're actually going to take a deep dive into a professional scientific publication. So we don't do that very often. And I hope I get most of this right. I am not a planetary scientist. I am not an expert in planetary atmospheres. And it's been a long time since I did any radiative transfer, which is what this paper was all about.
Yeah, and I'd just like to say that thanks to Wayne, because Wayne had a brief pitch, and when I mentioned to him that our speaker couldn't make it, Wayne kind of stepped up and made this a little more full. So
and I took full advantage of the offer to expand my presentation.
Well,
so the authors of this paper, it's Ben Jaffel and a whole bunch of other people. The title of the paper is The Enigmatic Abundance of Atomic Hydrogen in Saturn's Upper Atmosphere. this paper combines observations from a bunch of different spacecraft and spread out over almost 4 decades of spacecraft observations of the planet Saturn. You can see it's got Hubble data, Cassini, the International Ultraviolet Explorer, Voyagers 1 and 2. So they've taken all of these spacecraft observed Saturn in the ultraviolet, and they combined the data from all those satellites to do their study. Particularly, and why I got interested in it, it was because the Hubble Space Telescope's imaging spectrograph, the STIS instrument, and the Cassini ultraviolet imaging spectrometer, I believe it is, observed Saturn simultaneously in August and September of 2017, just before Cassini crashed into the planet Saturn. So it was last opportunity. And these authors realized that they needed to do these observations because it allows them to cross-calibrate the nearly in situ measurements from Cassini with remote sensing measurements from the Hubble Space Telescope. And that gives you a much better means of understanding what the Hubble Space Telescope is observing. And then it can be used for earlier IUE and Voyager data to make corrections to their calibrations. And what they did was they observed the Lyman alpha, emission in Saturn's atmosphere. And I'm giving a little bit away here, is they found that it's independent of longitude, and that rules out auroras as the source. That means there's some other source of the Lyman alpha emission. And since we're going to be talking about Lyman alpha, we better make sure we know what we're talking about. So over on the right in the chart is an energy level diagram for atomic hydrogen. And there are basically, for our purposes anyway, there are 3 sets of absorption and emission lines. Remember, absorption lines and emission lines occur at the same wavelength because it just depends on which direction the electron moves. And so out in the infrared on the very right-hand side, you have what's called the Paschen series. And in the middle, we have the Balmer series, which is everybody's familiar with because the hydrogen alpha, the H alpha emission line or absorption line is the lowest energy emission line, absorption line in the Balmer series. It's 65, 63 angstroms, okay? And on the left side of the diagram, we have the Lyman series of lines. And what these are is the arrows indicate a transition. In this case, they're showing emission lines with an electron falling from an upper level state to a lower level state. So if you look at, say, the H alpha line, that red one there in the middle left, the electron is in the second excited state, energy level, what quantum physicists would call n equals 3. And then the electron transitions down to the n equal 2 level. And when it does that, it gives up energy, and it emits that energy as a photon of light at a very specific wavelength. In this case, 6,563 angstroms. Okay, so these different series, the Paschen, Balmer, and Lyman series, are related to what the lower level is that's involved in the transition. So the Paschen series go from higher levels down to the n equals 3. Balmer series go from higher levels to n equals 2. And the Lyman series go from the higher levels to n equals 1, where n equals 1 is the ground state. Okay, so what we're talking about today is the Lyman alpha line, which, just like with the Balmer series, it's the lowest energy. So it's the line that's involved with the electronic transition from the n equal 2 to the n equal 1 state of atomic hydrogen. Okay.
So Wayne, that figure, the difference between the lines is not, I'm asked, this is a question, they're not to scale?
No, it's notional.
Okay.
You have the energies of the states listed in the right, to the right there.
Oh, I see, right.
Energy
Okay.
and electron volts.
I see.
Where zero is if you remove the electron completely from the atom, but it has no kinetic energy once it gets an infinite distance away. That's zero, and then it gets negative in turn because it's potential energy. It goes negative. So the ground state has an energy of 13.6 electron volts below the zero energy.
So if you if you don't mind me asking, like the last one of the Passion series, or the second to last one, the difference between the 7th and the 3rd state, looks like it's maybe around 1.5. So is that
It'd be about 1.2, 1.1, 1.2.
okay? So that's still
Right.
that's
Oh,
still-
right. You're right. I'm sorry. You said the 7th. I was looking at the 6th. You
so-
go from n equals 6 to n equals 3. It's about 1.1. So yeah, okay, maybe 1.5, maybe.
Okay, so that's still not in the visible. That difference is like drives the frequency, but that's still not in the visible.
That's in the infrared.
It's still in the infrared, because it looks
Yes.
almost like that. Just looking at the length of the arrow is not the right way to do it, because it's a log scale there. But like it looks like it's somewhere, almost the height between the hydrogen alpha and the hydrogen beta one there.
Well, if you think about it, the highest energy transition you can get is from 0 to whatever the energy of the lower level is. So, and for the Passion series, it would be 1.51 electron volts.
and that's
That's the
still-
highest energy. That's as blue as it will go.
Okay, and that's still not in the visible.
No.
Okay. Thanks.
Okay, so that's what we're talking about. We're talking about that transition from n equal 2 to n equals 1. They're on the far left of this diagram. That emission and that wavelength. Okay, so I've already mentioned the first result of the paper is that the Lyman alpha emission is independent of longitude, and this rules out auroras as the source. So if you go to the next slide, this will be a really quick one. Here's the evidence they presented of it. So we have the relative brightness of the Lyman alpha emission in the y-axis and longitude on Saturn as the x-axis. And the blue dots are from Cassini in April 5th of 2014. And the red dots are from Voyager 2 in 1980. So as you can see, there's just really no significant variation with longitude. And the reason this would rule out auroras is that if you think of auroras forming a ring, if you take a cut across the planet that crosses that ring, you would get enhanced emission when you cross the aurora, and you don't see that. So this emission that they're talking about is not auroras. Okay, thank you. I was just about to say that. So here's a couple more plots. What they did find is that the observations that they looked at for spanning 40 years all show the same characteristics, which implies that this emission is permanent. It's always there. Okay, so down at the bottom, we have a plot of the Lyman alpha brightness as a function of latitude on the planet Saturn. And on the left is the southern hemisphere, and on the right is the northern hemisphere. They had more data, or they presented more data on the northern hemisphere than they did in the southern hemisphere. So let's pay attention to the northern hemisphere plot on the right. And first of all, we're plotting on the x-axis the latitude on Saturn, and on the y-axis is that relative brightness of the Lyman alpha emission. Okay. On that northern hemisphere plot, we have a whole bunch of lines. The black line, the one that's real obvious, is from Cassini, back again on April 5th, 2014. The red line, which is maybe a little harder to see, is from Voyager 1 in 1980. And the aqua line, the light blue line, is from the Hubble imaging spectrograph data from September of 2017. And if you look at those three plots, they're all very similar. The Cassini data shows a little dip there at about 25 degrees north latitude, but otherwise it follows very much the same that the other data shows. And remember, this goes from 1980 to 2017, and it shows very similar behavior. The big peak to the right is attributed to auroras. So that's what you would expect to see from an aurora, is something way up there like that. What these plots show is that in both hemispheres, there is enhanced emission from about 5 degrees latitude plus and minus to about 35 degrees latitude, again, north and south. So there's that, basically that hump there at the low latitudes. Okay, no, go back, not quite there. The southern hemisphere shows the same kind of variation, but it's actually not quite as bright. It's not as enhanced as it is in the northern hemisphere. It's about 13% less pronounced. And so after coming to this, the authors then proceed to determine why this enhanced emission exists. That is, what could be causing it. So next slide. Okay, their approach to this problem was to perform detailed computer modeling of the radiative transfer, that is, how light behaves and moves around and affects the atmosphere in Saturn's upper atmosphere. Basically, since they were observing light, they need to understand how the observable light is formed, how they get it, why are they seeing it. And so this requires knowledge of the atmospheric constituents, which is also partly what they were trying to determine, is what are the atmospheric constituents that would produce the emission that they see. Let's see. So they need knowledge of the atmospheric constituents. They need knowledge of the radiative environment that those constituents experience. That is, what kind of light and how much of it are they seeing, and the interactions between the light and the constituents. In particular, they worked on the photochemistry going on in the Saturn's atmosphere. So they performed detailed modeling of the upper atmosphere to investigate the origin of the enhancement of this Lyman alpha emission. Their model used the solar X-ray and UV spectra for both solar minimum and maximum conditions. Okay, so they're considering basically light in the X-ray and ultraviolet regions of the spectrum. They're not worrying about visible, because visible doesn't do much at the wavelengths of Lyman alpha. Their model includes Lyman alpha photons from the sun, and they even put in the modification by the interplanetary hydrogen, because that will affect the insolation, they call it, insolation, they call it, of the Lyman alpha light at Saturn. They also included effects from the solar cycle and Saturn seasonal effects, and also the Lyman alpha sky background photons. So they even included a little bit of Lyman alpha they get from the general sky. That's probably largely scattering from the zodiacal light, I would guess. They also had a photochemistry model that considered scattering of the photons by hydrogen. Now, it considered Rayleigh scattering by hydrogen, which turns out not to be an important contributor, and absorption by hydrocarbons and water molecules. So now we're getting close. Is it hydrocarbons? Is it water? What is it? They also considered then the chemical production, loss, and vertical transport of the various species. Okay, so they did a lot of work. They put a lot of computer time in and modeled, and very careful physical modeling of what was happening in the upper atmosphere of Saturn. Okay, if I haven't scared you away yet, this next slide will do it. So next slide. Okay, so this is what the detailed modeling produces. It's basically a plot similar to this. This is a plot of the atmospheric composition at different heights and the temperature of those constituents at different heights. So on this plot, the y-axis is the height in the atmosphere expressed in kilometers, with 0 being the height at which the pressure is the same as the pressure at the Earth's surface. Okay, just use that as a reference point. Okay, so they're working in pressure, but they've converted it to height in kilograms or kilometers, excuse me, kilograms. The x-axis is the density at the bottom anyway, is the density of the various atomic and molecular species that they were tracking. And that's in particles per cubic centimeter. And as you can see, it goes from about 10 to the 432, about 100 particles per cubic centimeter all the way on the left, to about 10 to the 18th particles per cubic centimeter all the way on the right. So that's a big range in density. And the x-axis at the top is temperature in kelvins. There are several groups of lines in this plot. So there are 2 temperature curves. If you look on the upper right, you see a letter T. There's a purplish looking curve and an aqua curve. Those are both temperature, and they come down and they swing to the left and go almost horizontal, and then at about 10 to the 5th in the density scale, we're talking temperature, but just that point on the plot, they fall quickly down. Basically, the atmosphere becomes isothermal at that point with altitude, and then it gets kind of squiggly as it goes down to the bottom of the plot to get down to the 0 altitude site. Okay, let me get my notes here. The purple curve is the vertical temperature profile based on a stellar occultation that was reported that happened in 2015 and is associated with the black curves in the rest of the plot that I'll get to in just a minute. The aqua curve, the bluish curve, that's a lot steeper there at just to the left of 400 kelvins, is their seasonal model that they've used for this paper. And this particular model happens to correspond to 2 degrees north latitude, and it's with Saturnian summer solstice conditions. Okay, so this is the seasonal. So that's one set of curves, and that uses the upper x-axis because that's temperature. There's 3 other sets of curves for the important constituents that they were considering. If you go to the far left, you see methane or CH4. There's a couple of curves there. There's a blue one and an aqua one that kind of go off diagonally down to the right. There is going to the above and to the right, you find an H, which is for hydrogen, and there's actually 3 curves for hydrogen. I'll get to more in a minute. And then further to the right, there's a couple of curves for molecular hydrogen molecules, or H2, Arabic number 2. Okay. If you look at the 3 curves for hydrogen, there's a black curve, a red curve, and an aqua curve. The black curve for all 3 of these species represents the solar minimum conditions with that purple reference temperature curve. Okay. I got lost in my notes here. Yeah. Okay. The red curve on hydrogen uses that same purple temperature curve, but reflects solar maximum conditions. And the aqua curves come from the seasonal model so the aqua temperature curve at 2 degrees north and Saturnian summer solstice. Okay. So what you can see here is it's methane is one of the primary constituents. Methane and molecular hydrogen are the main constituents low in the atmosphere. If you look at the lower right of the plot, the molecular hydrogen and the methane are very high densities, up to 10 to the 17th to probably 10 to the 19th or 20th particles per cubic centimeter at the 0 altitude line, whereas the hydrogen is way down at about 10 to the 6th, about 1 million particles per cubic centimeter. So at the 0 altitude, the main constituents of the atmosphere are molecular hydrogen and methane. atomic hydrogen is almost insignificant. But as you go up in the atmosphere, the methane falls off really fast, and the hydrogen, the atomic hydrogen becomes much more prominent in terms of the composition. The overall density is dropping, then hydrogen becomes a much more important constituent at these upper altitudes. The molecular hydrogen also falls off as you go up in height, but not nearly as fast as the methane. Okay, everybody still awake?
Yeah, I'm.
So,
It's like you would think that the methane is heaviest, so it would be down at the bottom, and then the hydrogen is lighter. But I'm waiting for the punchline because I'm curious as to know why.
that is the punch. That is a large part of the punchline.
Okay.
So hydrogen becomes dominant basically at the upper parts of the atmosphere.
And it wants to live in its H2 form, not in its H form.
Yeah, and that's more a matter of the temperature. Okay, because it once as you get cooler, you tend to form molecules. Right? I mean, M stars have molecules, O stars don't.
Right.
Right. So as things get cooler, you tend to form molecules because the energies are sufficient. The energy of motion is sufficiently low that it can't overcome the molecular bonds that form if they ever form them. So you tend to get molecules at lower temperatures. Okay. So they ran so the point of me showing you this plot isn't so that you learn a whole bunch of radiative transfer and chemistry, photochemistry, and all this kind of stuff in planetary atmospheres. But this is the kind of thing that professional scientists are looking at. You know, we like to look at the pictures, and I like to look at the pictures. I get that. But when you're trying to do the science, you're not so much looking at pictures, you're looking at the output of computer programs, in this case, particularly in terms of graphs and stuff. So I ran these kinds of models. This, remember, is for 2 degrees north. They ran the models for 7 different latitudes between 12 degrees south latitude and 70 degrees north latitude in order to map the atmospheric properties through the region of enhanced emission. So that's what they were looking at. That's the kind of data they're looking at, or kind of results they're looking at to try to interpret. So I guess we're ready for my last slide. So they established that reference atmospheric model based on solar minimum conditions in 2017, and their modeling shows the need for 2 to 3 times the amount of atomic hydrogen that their reference model had in it in order to explain the latitudinal emission brightness. And actually they looked at the line profile of Lyman alpha also, but mainly, you know, the latitudinal emission brightness. And so they need more hydrogen in the upper atmosphere than has been, I'll say, previously accepted. And the source of that hydrogen is possibly the rings. It could be Enceladus, but they tend to favor that it's coming from the rings. So we got water coming into the upper atmosphere from the rings, and it causes the enhanced, it enhances as the water molecules are broken apart by the photochemistry from the Lyman alpha, the ultraviolet light, then you get atomic hydrogen, and the atomic hydrogen, the more of it you have, the more Lyman alpha emission you'll get.
I have a question, Wayne.
Okay.
Doesn't Enceladus produce the E-ring? And so when it says hydrogen is possibly water originating in the rings or Enceladus, isn't the E-ring created by Enceladus?
I will accept that, but remember the E-ring is one of the most outermost rings, and so it's not going to at least directly be dumping water onto the atmosphere of Saturn. That's going to be coming through from the crepe ring,
Yes, got it.
right?
Thank you.
So.
Yep.
Now, that doesn't mean to say that Enceladus isn't the source of water that's producing the rings and the particles eventually migrates down to the atmosphere. I'm not in a position to argue that one way or the other.
Right.
But,
Thank you.
So
okay.
these models have like the atmosphere of the Earth is they have the people who are developing these models, they are they, you know, are they basing some of their modeling on like what they've observed on our planet as well?
As a general rule, I'm going to say yes. But I would say it's more from the point of view of that they develop their models, their computer programs, if you will, and they will use the knowledge of the Earth's atmosphere to verify their computer code. Right? I mean, it's basically, you know, the Earth's atmosphere is basically like ground truth. So if they can reproduce the Earth's atmosphere characteristics with their model, then that gives them confidence that their model is working right.
I have one other question, and that
Okay.
is where was the one that Earth one bar, this one, so 2,500 kilometers, so this is really just the very outer tip of the atmosphere there. I mean,
Yes.
the planet is gigantic compared, this is just the very last top of it, is that true?
Yes. Yes. So if you entered the Earth's Saturn's atmosphere and got down to a pressure of 1 bar, that's what they're calling, I'll say, the surface.
So you get you know, if the center, it's just way more dense as you continue to go down, then I guess.
Oh yes.
Yeah.
In fact, they think there you might have things like metallic hydrogen, or maybe I'm confusing that with Jupiter, but yeah, things get very dense down in the centers of these planets.
All right. Okay.
They're probably a rocky core, but I don't know if they know that for fact. So
that was pretty cool.
So like I say, this was a deep dive into a professional publication.
Thanks. That was awesome. I appreciate that, Wayne. That was really cool. Anybody got anything else and for Wayne, any other questions? All right, well, if not, then I'll go into members Astro Images and Sketches, and the first one, given Jim's Shallow Sky. Steve, are you Steve on? Yeah, Steve's here. You want to talk about these guys?
Yeah, I don't know. Can you hear me?
Yes.
Oh, okay. Yeah, it's pretty self-explanatory. These were just taken the other night. And I don't have a ultraviolet filter, so you don't see any detail on Venus, but Venus is so bright now, it's really easy to get. Mercury, you have to get it just at sunset, really, because it disappears very quickly. And you can see the altitude was 12 degrees for Mercury, so it's really getting pretty low.
Yeah, there's a certain amount of atmospheric dispersion going on in that picture too.
Oh yeah, yeah.
Still, it's amazing you're able to get, that's not a lot of arc seconds going on there.
Right, so you can, the point is to see the phases. I mean, the color is always going to be weird.
Right.
The point is to see the phase.
Right.
Yeah.
Hey, Steve, did you process that in Registax?
Yes.
And for your Mercury one, did you use the feature where you can kind of remove some of that atmospheric distortion?
No, I kind of liked it the way it was.
Okay.
I mean, the colors of all of your images are dependent on what the person who's processing likes to see.
Yeah,
So-
absolutely.
Yeah.
Awesome. And so along the same theme, here's Jim.
Yeah, just the other night, finally, we have had such lousy weather in terms of seeing. Finally had a decent night the other night, and so got some images of Venus. I've got the IR there, and you can see, the Ratten one, what I was discussing, where you can use a Ratten filter in an IR block. It actually picked up a little bit of an area there that clearly is kind of like absorbing a little bit of like deep blue, ultraviolet in the cloud. And they really don't know what the chemical is. They really don't know what it is that's in these dark spots, what in UVA that's absorbing. And then the UV one, you can kind of see the cusp caps that I was talking about earlier in that one in the bottom right-hand side. As for Mars, like I said, real tiny, but you can still pick out some stuff. You can see this is with south up here. So that's the northern polar cap with what they kind of call like a Lowell band, a little bit of a darkening albedo kind of coloration against the polar cap rimming it. And then kind of a broad, indistinct albedo Mare Erytharium up at the top there. So it would be probably more interesting if more the recognizable albedo feature like Syrtis Major or something was there. But, if you get a night with some halfway decent seeing and you're into doing some imaging, you can still pull out some features, even though the thing's down to almost Mercury size level.
That is amazing that you've got any features at all on there. That's just so awesome. That's so cool. And then just to highlight that, I don't think he's on, but John had put this in, he had sent this, just to get a flavor for just how tiny these things are and how amazing it is that you guys can get these images. That's Venus and Mars. I mean, oh no, I'm sorry, Mercury. Is that Mercury?
It should be, yeah.
Yeah.
Mars would be a lot higher.
Yeah, ours would be higher. Anyways, Steve.
Oh, yeah, sorry. Yeah, this was with the Hyperstar adapter on my 14-inch Celestron. Pretty nice shot of M51. My name is spelled with a PH, by the way, not a V.
I'm sorry.
So it's, again, I mean, it's pretty self-explanatory, I guess.
So how many, was this really a quick exposure? Did you take much?
Oh dear.
F2?
It's a number of frames stacked. It doesn't take very long. It was probably about 8-second exposure and probably 16 images stacked.
Awesome.
That's usually what I do. Yeah.
Awesome.
Yeah.
thanks.
It's the Hyperstar works great, but the sky here is so bright that it's tough. I really wish I had a dark sky, but so be it.
Yeah. Okay. Well, I want to talk about that. That's something I want to send out a survey to the club, but I want to talk about dark skies and remote star parties and stuff like that, but we'll save it for later. Thanks, Steve. And this is Jim Johnson. Are you on? This is just a really beautiful picture. So this is with his 4-inch refractor and on his Las Mandy. I wish Jim was here to tell us more about this picture, but it's a pretty gorgeous view of M81 and M82. And then Phil. All right, Phil's still here. Did he fall asleep yet?
Still here. No, I'm digesting Wayne's slide here, just trying to get it done so I can repeat it to my wife, who I'm sure is waiting up to hear all of that. So This is the device here is a night vision device, which is actually the same night vision device that the U.S. Army and Marines use. In fact, when I got it, it came with a helmet mount. So, and Teleview has worked it out with this company T&V, Tactical Night Vision Company, where they provide this device to Teleview with white phosphor, not green phosphor. And what it effectively does is when I put it on my telescope, now it won't work with all eyepieces. It'll only work with Teleview eyepieces and a large select group. So it's not just a few of them, but you have to have the right ones so you could put it together. It's got several adapters in order to get it onto the eyepiece. It's got a 48-degree field of view. That's what it is. And you're actually looking at the screen on there when you've got it dialed in. Effectively, it triples the power of your telescope. So my focal length on my 5-inch refractor is about 1100 millimeters, and it becomes a 3300. So what you've got there, and this was actually, I took the night that Wayne was out there with me at Alpha Ridge, and we were looking, and what you see in M46 in the upper right, there's a very bright spot in there, and that bright spot is actually a planetary nebula that we were able to see at Alpha Ridge buried inside M46. You would not be able to see that with my 5-inch telescope without that. And to check that, we got the star map out and went through it and found that that's exactly what it is. So that was, the image in itself, which you're looking there, is nothing spectacular, except for the fact that it's drawing something out in relatively light polluted sky there at Alpha Ridge. So these are some images, and these images that were taken with my iPhone 14 and with an instantaneous shutter snap. No, it's just taking a picture of what you're seeing right with the night vision device. On the bottom right is the Orion Nebula, and the things that you could pull out of an emission nebula with this is really quite spectacular. You could certainly very clearly see in the eyepiece. I didn't get it in this one here. Use it a little further up, but Barnard's loop is just super prominent when you don't have any magnification on it. You just hold it up. You just put that eye cup on your eye and you hold it up to the sky and you look up and you can see Barnard's loop as clear as day. And you could see any of the large nebula. And Victor, you were out there in Pennsylvania when we were in a dark sky. Looking.
I'll attest to that. We were just scanning the skies with that thing. It was amazing. We're just looking, and then all of a sudden, you could completely, very distinctly see the Heart and Soul Nebula just pop out of the night sky, looking through that thing.
Yeah, no magnification. Is a 1-to-1.
That was with an
Amazing.
H-alpha filter?
Yeah, so it's got, yes, it does. I had an H-alpha filter on the a 0.6 nanometer H-alpha filter on the end of the device, right? Yep. So, and once again, and with these images, not only was it at Alpha Ridge, it was almost a full moonlit. It was a very bright moon that night. So we were able to pull these things out. But when you get a chance to come out when I'm out at a star party with this, and you get a chance to look at it, it's just incredible. I'm looking forward to putting it on the Big Mead for a star party in the future. I won't be able to make it out this weekend because I have something else going on. But in the future, to pull that out and put it on the Big Mead and turn that 14-inch into basically a 42-inch mirror telescope, what you're gonna be able to pull out is going to be quite incredible. Any questions? Thanks, Victor.
All right, well, that concludes our agenda for tonight. I'm going to stop the recording. I don't want to end the meeting yet. Let me stop.
Can I toss one more announcement in?
Oh, please, yes.
Well, sorry, I should have mentioned it at the beginning, but my observatory at Glen Elk Country School will be open tomorrow night, Friday, from sunset to 10:30. So I always appreciate when you guys come out. The kids love it too. So if anyone's interested, my observatory at that school will be open. Again at Glen Elk Country School from sunset to 10:30, and it is open to the public. Everyone's welcome, and hope to see you there.
Great. I think it's totally cool if you want to send a message to the membership too. Just send something out to the main distribution. Thanks, Crystal. All right, I'm gonna stop recording, but don't disappear yet.
Victor, isn't there, we also have I think, somebody sent out a call for volunteers for this coming Saturday. Will be at Clarksville Commons. Bob, you'll be coming out. Bob Savoy, if you're still here. I think Bob's coming out. Phil's coming out.
Yes, I am. But it's it doesn't look very pleasant weather-wise.
Oh, sorry to
It
hear
looks
that.
like all the clouds are going to be, and even rain maybe.
Oh,
So
that sucks.
yeah.
Yeah, Richard Wren sent out a message to the group, to the distribution. But yeah, it's not looking so hot for the
Oh,
afternoon.
too
there.
bad.
All right, thanks. I'm gonna stop recording. This concludes our April meeting. Yay.